In this video, we're going to learn how to classify both direct and inverse variation, and then we're going to learn how to write equations that have direct and inverse variations. So before we begin actually classifying direct and inverse variations, we need to define what these two types of variations actually mean. So a direct variation is when two variables essentially form an equation that looks like y equals a times x for some non-zero constant of x. So when two variables have direct variation, essentially what happens is as one variable grows, the other variable grows. You can see that here. Y equals a times x. Well, if x becomes bigger, so regardless of what a is, if x becomes, 4, or if x becomes 6, or if x becomes 8, that causes the y value to grow larger and larger and larger. So if we have an equation and we can rewrite it into this form where a is a non-zero number, we have a direct variation. On the flip side, two variables show an inverse variation when they can be written in this way: y equals a divided by x. And essentially what happens here is as x grows, y is going to become smaller. So for example, if x was, 2, it would be a over 2. But then if x was 4, it would be a over 4, which would make y smaller. So here what's happening is as x increases, y increases. But here in an inverse variation, as x increases, y decreases. And for both of these situations, what we're going to be looking for is if we can rewrite it into one of these two forms where a is a non-zero number. So that's what we're going to look for as we try to identify direct and inverse variation. So for each of these three situations below, what we're going to do is we're going to determine if the equations have direct, inverse, or neither type of variation. Remember, if we have direct variation, we're going to be able to rewrite those equations into y equals a times x form, where a is some non-constant value. And if we have inverse variation, we're going to be able to rewrite it into the form y equals a over x. So that's what we're looking for, either y equals a times x or y equals a divided by x. So here in this original equation here, in number 1, what I notice is that my y value is not alone. So for each one of these equations, what I'm going to do is I'm going to rewrite it so that the y value is in fact by itself. Now I notice here that y is being divided by x, so I'm going to start by multiplying by x on each side. So I have y equals 8 times x. Now that I've gotten y alone, I look at both the equations for direct and inverse variation. And what I notice here is if I set my a value equal to 8, this looks directly like the direct variation equation that I see here. We can see that y equals a times x. Well, here a is 8, so we have direct variation because this equation type matches the direct variation. Now if I look at example 2, here I'm going to start by getting y alone, so I subtract x from each side. So I have y equals 7 minus x. Well, when I look at my two types of equations, this doesn't look like either type. Even if we wrote this as y equals 7 plus, a negative 1x, and we set our a value as negative 1, this plus 7 here is complicating things because we didn't include any additions or subtractions in direct or inverse variation. So just from looking at this, we can say it has neither type of variation. Then from here, if we look at example 3, again, our goal is to get the y value by itself to help us classify direct, inverse, or neither. So I notice that I'm multiplying y by x, so I'm going to divide both sides by x. So I end up with y equals negative 3 over x. Well, I notice that this looks just like the inverse variation equation if I were to set a equal to negative 3. So here we have an a value equal to negative 3. that looks then just like the inverse variation equation. So this has inverse variation. So in this slide, we're going to tell whether the tables below with x and y show a direct, inverse, or neither variation. And remember, our direct variation will result in the equation y equals a times x. Inverse variation will result in y equals a divided by x. Now, what we can do here is we can actually use these equations and manipulate them a little bit to look for patterns. So what I'm going to do here is I'm going to actually rewrite this direct variation equation and this inverse variation equation for A. So direct variation, if I rewrite it for A, I'm going to divide both sides by x to get A alone. So I have A is equal to y over x. Then if I have inverse variation, and I want to get A alone, I'm going to multiply both sides by x. So I essentially have x times y equals a. Now what I'm noticing here is that when I have direct variation, I notice that my y values divided by their corresponding x values always result in this constant. Remember that a is a constant value in our equation. And in inverse equations, when we multiply the x and the y values together, we get a constant of a. So what I can look for is I can test every combination of x and y and see if there's a pattern either with y divided by x or x times y. So here I'm going to test y divided by x first for each one. So here if I look, if I take this first point here, I have negative 12 divided by 2, which is negative 6. And then this next one here, I would take y, which is negative 6, divided by 4, which is negative 1.5. Then here I would see, okay, negative 4 divided by 6, that's negative 0.75. So I'm already noticing here that this isn't a direct variation because I'm getting different values each time. So there's no way I could really rewrite this equation so that y equals a times x, because here we have an a value, we would need an a value of negative 6. Here we need an a value of negative 1.5, and here we need an a value of negative 0.75. But if I flip this around and maybe look for inverse variation, and I look at x times y, I'm going to notice something different. So here if I take 2 times negative 12, that's negative 24. 4 times negative 6 is negative 24. 6 times negative 4 is negative 24. 8 times negative 3 is negative 24. So what this is telling me is that I potentially have an inverse variation situation here. So I'm going to move this up just a smidge. And I'm going to actually test this out, because what this is saying here is if I have this constant that is resulting every single time, this is saying that I have an inverse variation with an a value that's equal to negative 24. So if I rewrite this equation here, essentially what I could say is that xy equals negative 24, and then rewrite this for y, so y would equal negative 24 over x. So I'm thinking this is an inverse variation with an a value of negative 24, because I can write my equation in this way. Now if I test this out, and I look, okay, negative 24 divided by 2 results in negative 12. Negative 24 divided by 4 results in negative 6. Negative 24 divided by 6 results in negative 4. Negative 24 divided by 8 results in negative 3. So by looking at these patterns and trying to figure out what A is, if it was a direct or an inverse variation, we're actually able to not only determine that this is an inverse variation in Table 1, but we're able to also determine that we have an equation which is y equals negative 24 divided by x. So now let's take a look at table number 2. So here we're going to test for the same things. We're going to start looking for, can I find a constant with y divided by x, or can I find a constant with x times y? So here, if we take a look at the first pattern there, so we have y divided by x. Let's see what happens. So y divided by x, I notice I have 2 over 1 for this first one, which is 2. This next one here, I have y divided by x. That results in a 2. So it looks like we might have a pattern here, but we need to test all the way through to make sure. So here we have then 8 divided by 3. That results in about 2.67. And then we have 16 divided by 4, which results in 4. So because I'm not getting a constant number, even though I had a constant number for those first two, this can't be a direct variation because I don't have a consistent a value. So then from here, I'm going to look for an inverse variation. So if we flip that around and do x times y. Okay, the first one we have 2 times 1, so it would be 2. 4 times 2, which would be 8. 8 times 3, which would be 24. And 16 times 4, which would be 64. So because when I divide them with y over x and multiply them with x over y, I'm not getting constant a values, I can say this is essentially not a direct variation because of this first proof here. And I can also say that this is not an inverse variation. So this is some other type of equation. And because it doesn't fit either pattern, I can simply write that this is neither variation. Now, if you want to know why this is neither variation, this is actually the equation y equals 2 to the power of x, which doesn't fit into a direct or an inverse variation equation type. So in this final slide, we're going to learn how to write inverse and direct variation equations. So here it says the variables x, y are vary inversely. So we know we're going to have the relationship type of y equals a over x. And when y equals 5, x equals 8. Write an equation that relates x and y. So we know for sure they vary inversely, and we know this one pair. So what we can do is we can use this one pair of values to help us find our a value, because that's really the important piece of an inverse variation equation. So we have y equals a divided by x. But right now we know that one pair that works in this equation is y is 5 and x is 8. So what we can do here is we can rewrite this equation so that we know what the a value is. So we're going to multiply each side by 8, and we end up with an a value that is equal to 40. So our inverse variation equation here is y equals 40 divided by x. And then from here it says to find y when x is equal to -2. So now we can apply this equation here. We can say, okay, we're going to find y. So we have y equals 40. We know that x is -2. So that makes y equal to -20. Now the second one down below says the variables x and y vary directly. So when we vary directly, we know we have y equals a times x. And this occurs when y equals 5 and x equals 8. So it's similar to the above, but it's different because we're varying directly. So when we vary directly, we have the equation y equals a times x. We need to figure out which value for a makes this equation true. So here we start off and we input our values. So I have 5 is equal to a times 8. And I want to find the value for a. So I divide each side by 8. So I end up with a is equal to 5 over 8, which is approximately 0.625. So my equation here is y equals 0.625 times x. Now from here, I want to find the value for y when x equals -2. So all I need to do then at that point is take my direct variation equation, write it into y equals 0.625 times -2, determine what that would be. If I multiply 0.625 times -2, I end up with y equals -1.25.